All right, so in the very first video, we looked at the rules associated with order of operations and the distributive property. In the second video, we looked at some examples of order of operations. And now in this third video, we're going to take a look at some examples of the distributive property. But a quick reminder as we get started here, the distributive property is not its full name. Remember, our learning objective said that it's the distributive property of the real number multiplication over addition. Okay, so that big name is telling us when we can use it. We can only use it with multiplication and addition, or division with addition, or multiplication with subtraction, right? Because remember, multiplication and addition happen in the same step as divides and subtracts. So we've got to have some combination of those things if we're going to use the distributive property. We can't use it if we have other types of operations. So you've got to keep that in the back of your head as we get started here. We're going to start with the first example, nice, simple, straightforward, an example where the distributive property does work, okay? The distributive property works when you have multiplication with addition. That's fine. So if I distribute the 3, distributive property tells me that I'm going to send it in and multiply each thing in the grouping symbol by that 3. So now I'm going to have a 3 times a 4 when I distribute it to the first thing, and then a plus and a 3 times a 5 when I distribute it to the second thing. Okay, that's my distributive property in action. Now I can do my multiplies. 3 times 4 is 12. 3 times 5 is 15. And then I can add those together. 12 and 15 are 27. So that's a very simple, basic, straightforward example of the distributive property. Okay, again, example 2, it also works if I've got other things like subtraction or division or things like that. So let's take a look at a -2 being distributed over 5 minus 3. So now I'm distributing multiplication over subtraction. That's still okay. That's still legal. It's just going to look a little bit different. So when I distribute here, the negative is part of this number. It's a -2, so it goes with it. So I get a -2 times a +5, and then minus a -2 times a 3. So that's distributing over a minus sign. Now I do my multiplies. -2 times 5 is a -10. Minus -2 times 3 is a -6. And I'm going to put that -6 in parentheses so my signs don't get mixed together or confused. Okay, now you probably remember from other algebra classes or pre-algebra or things like that, subtracting a negative is the same as adding. The signs change. So we've got middle school teachers in our district who like to go chum chum, or some will say change, or chum chum boom boom, or however, whatever. But the bottom line is those signs are going to change when we subtract a negative. And so I end up with a -10 plus 6, which will equal -4 for my final answer. Okay, so that's the distributive property over subtraction. Let's do one more simple example or basic example where the distributive property works. So here's example number 3. And we're going to do this with a distributive problem that has division. So I'm going to say I'm dividing 2 into a 6 plus 4. Now notice here there's no parentheses, but the 6 plus 4 is inside of this fraction. And remember, a fraction bar means divide. So this divide is acting like a grouping symbol. So order of operations would tell me I should do the top first and then divide second. And that's, again, why we don't do parentheses, exponents, multiplies, divides. We do grouping symbols, exponents, multiplies, and divides, okay? Because there's more than just parentheses. So I should end up with 5 for my answer. But the distributive property still works. I'm going to distribute the 2 to both halves of my fraction. So that's going to give me a 6 over 2 plus a 4 over 2. And if I divide these, 6 divided by 2 is 3, 4 divided by 2 is 2, and 3 plus 2 gives me 5. So that would be an example of the distributive property where I'm doing a division over addition. Okay, so again, this is a workaround to the order of operations. If you don't like this, that's okay. Do the normal order of operations method, and that's okay. There's not a problem with that on this particular situation. All right, now what I want to do is I want to end with one more example that's going to look very different. Suppose I have 4 multiplied by the quantity 2 plus 3 quantity squared. Okay, now I want you to think about what is different on this problem. That's right, this problem has an exponent, okay, which makes it different. So our rule, the full name of the distributive property is the distributive property of multiplication over addition with real numbers. But let's think about order of operations here. Do exponents come first or do multiplies come first? Well, exponents do. Exponents come first. So this exponent demands to be taken care of before I multiply. And are exponents allowed to distribute over addition? They are not. And because exponents don't distribute, that means I cannot use the distributive property on this problem. All right, so as soon as an exponent comes into the game, that is my cue that I must use order of operations. Okay, I cannot use the distributive property because there's an exponent. So let's go back to our normal order of operations. We have to start with what's inside the grouping symbol first. 2 plus 3, that would give me a 25. I'm sorry, 2 plus 3 is just 5, isn't it? But then when I square 5, because exponents come after grouping symbols, that's when I get a 25. 5 squared equals 25. And now I can finish with 4 times 25, which is 100. Okay, I'm not going to do it in this video, but if you tried to distribute this first and then do the square, I promise you, you're not going to get 100 as your answer. You can give it a try, see what happens. You won't get 100, okay? So there's our final video for this section on simplifying numerical expressions. Thanks for watching.